Okay, we're going to start talking about a Chapter 5 practice test for the Algebra 2 Honors course. This one says y varies directly as x. That simply means y equals a constant k times x. If they give me a complete set of data, which usually they'll give you an x and y pair, plug them in. What's the y? 12. What's the x? 3. If I divide by 3, what does that make k? If I divide by 3, I think k is going to equal 4. Do you agree with that? So when I rewrite this, instead of k times x, I'm going to put y equals 4 times x. All I did was replace the k with a 4. Now it says to find y when x is, find y when x is 8. So if I replace the x with an 8, I think that makes y equal 32. So that would be your answer for number 1, using direct variation. Direct variation again is y equals k times x. If it says inverse variation, that means something different. That means y equals k divided by x. Some people notice that if you happen to cross multiply, you'd get x times y equals k. Does this give me a complete set of data of ordered pair? It should give me an x and a y pair, right? So I don't care, as most people like to plug it into here to find k. What is your complete data that you're going to plug in? Again, it's right here. I'll do it in red. X is negative 12, y is 2/3. When you multiply these, how many times you get negative 24 over 3, right? So I think that makes k negative 8. Now that you know what k is, you can substitute that into here. So what is my k? Negative 8. I have an equation now. Now they want us to find y when x is what? Well, I think it says right here when x is 3. When x is 3. So I'm going to put a 3 in, and my answer for this is going to be y equals negative 8/3. Okay, after 1 and 2, which are variation questions. 1 is direct and 2 is inverse variation. Now we're going to sketch graphs of rational functions. This is a sketch of what they call a basic rational function. You may notice what value makes the denominator 0, because that's when x equals 3, that creates a vertical asymptote. Why? Because it causes division by 0. So I'm going to go to where x is 3, and I'm going to create a vertical asymptote. Horizontal asymptotes, most people on these type are simply going to remember that the horizontal asymptote is simply this last number. So the horizontal asymptote is going to be y equals 2. So where y is 2, I'm going to create a horizontal asymptote. Now you just need to pick a number on either side, because it cannot be up here and down here and still be a function. It fails the vertical line test. It'll only be one or the other. It can't be top and bottom. What do you get if you put in a 4? What happens if you put in a 4? You'd get 1 over 1 plus 2, which I think is 3. That's up here, isn't it? 4, 3. And I know that it has to curve from one asymptote towards the other asymptote. Notice I labeled a point. I labeled my asymptotes. That's what I mean when I say label all that you can. How about a 2? If you put in a 2, what happens? If you put in a 2, what do you get? Negative 1 plus 2. What is negative 1 plus 2? 1. So I think that's going to go through 2, 1, which means it has to curve from one asymptote towards the other asymptote. And here's a graph for number 3. Okay, now we're going to graph a little more complicated rational right here. Again, I'm going to ask what value, and I'm sorry, I want to have x squared minus 4 on the bottom. I apologize. Otherwise, it would have had a slant asymptote, and I do not wish to do that to anybody right now. Maybe a bonus, but what value makes the bottom 0? I believe 2 things, because if you actually factor the bottom, it would be x plus 2 times x minus 2. So I think at 2 and at negative 2 create vertical asymptotes. So I'm going to make a vertical asymptote at 2 and at negative 2. Now I'm going to look at the powers to find the horizontal asymptote. So let me write that out. What do we have? We have a vertical asymptote at 2 and negative 2. The horizontal asymptote, you look at your degrees. If the power on bottom is bigger, the horizontal asymptote is at 0. Here the powers are the same. So you divide your leading coefficients. What is 1 over 1? So the horizontal asymptote is when y is 1. So that's going to create a horizontal asymptote right when y is 1. Now again, we just need to plug in numbers. If I put in a 0, what would I get out? 0 squared over 0 squared minus 4. 0 over almost anything is 0. So this goes through 0, 0. If I put a 1 or a negative 1 in, what would I get? Negative 1/3. So you have 1 and negative 1, so that's 1 negative 1/3. Notice that they're below. You also may notice that all the x's are to even powers, which makes this an even function. You don't have to tell me that, but if you notice it, maybe you will. By being an even function means it's y-axis symmetric, and I have to be able to fold it on the y-axis and have it match up. If I folded this on the y-axis, would they match up? I hope that this point would match up with this point. Now let's try putting in something like a 3. Again, it can't be both. It can't be top and bottom. So if you put in a 3, you'd have 3 squared over 3 squared minus 4, which I think is 9 over 5. Almost 2. So that's up here. Just up to almost. I got to have it at the 3, though. So it'd be at 3, 9/5. And now I know it's going to curve from asymptote to asymptote. What happens if you put in a negative 3? Well, you'd get the same thing. Negative 3 9/5, which again, asymptote to asymptote. If I folded this on the y-axis, they should match up because this is an even function. I don't know if you're aware, but 0, 0 is called a relative maximum. When I say a relative maximum, compare it to points immediately to its left and immediately to the right. Is 0, 0 the highest of those points? That makes it a relative maximum. If it was the lowest point, it'd be the relative minimum. Anyway, here's the sketch for number 4. Okay, after 4, we're going to 5, which is simplify. I'm just going to multiply all my numerators. 80 times 1 is 80. What's x to the 4th times x to the 1st? You add them would be x to the 5, and then you have a y. On bottom, 5 times 1 is 5. You have an x squared and a y to the 3rd. 5 goes into 80 16 times. How many more x's are on top? You would subtract 5 minus 2, so you'd have 16x to the negative 3. I'm sorry, 16x to the positive 3. What happens if you subtract your y's? What is 1 minus 3? Negative 2. If you have a negative exponent, it just goes to the other side of the fraction and becomes a positive exponent. I usually take it at this point, change it to 16 over. How many more x's are on top? 3. How many more y's are on bottom? 2. So either way, we should get the same result. Okay, after 5, we're going to move to 6. This is multiplication was the last one. This is division. So this involves factoring usually. I notice that this is a perfect square. I notice that this is a perfect square, meaning it's probably a perfect square. 4x minus 1 times 4x minus 1. I believe that gives me 16x squared minus 4x is negative 8x, and last times last gives me 1. On bottom, you have an x to the 3rd minus 7x to the 2nd plus 12. Can you factor an x out of all those? That'd be x squared minus 7x plus 12. Are there factors of 12 that add to negative 7? Negative 4 and negative 3. So on bottom, I'm going to have x times x minus 4 times x minus 3. Because this is division, you're going to change it to multiplication and multiply by the reciprocal. 15x cubed could be 15 times x times x times x, right? What can I factor out of this, which is now on the bottom? If I take a 5x out, I think it leaves me with x minus 4. Does that look right? No. I need 20x squared, so that 5 times 4x, that'd be 20x squared and then minus 1. Because it's multiplication, it can be considered one big fraction. Some things might divide out of the top and bottom if they're factors. You may notice one of these x's will cancel. Does anything else cancel? Another x, it looks like. Anything else cancel? So now on the numerator side, on the top, I see a 15 and I see an x. And I see a 4x minus 1 that remains. On the bottom, or the denominator, I see a 5, I see an x minus 4, and I see an x minus 3 remaining. And that should be my result. Okay, after 6, we may be moving to 7, which I think we're going to be getting towards addition, subtraction, and then equations. This one is a subtraction. You need a common denominator to add or subtract fractions. So this factors into x plus 1 and x plus 3 because they multiply to 3 and add to 4. This denominator factors as the difference of squares, x plus 3 times x minus 3. What would be my common denominator if I took the highest power of every denominator that you see? I think I could turn it into this. What does the first one not have in its denominator? It has the x plus 1, it has the x plus 3. What does it not have? X minus 3. So that gives me x squared minus x minus 6 if I multiplied it. What does the one on the right need? It has the x plus 3 and the x minus 3. What does it not have? The x plus 1. So if I did this, I'd now have a common denominator. I don't know if we want to distribute this as a negative 5. So that'd be a negative 5x. What's negative 5 times 1? Negative 5. So cleaning the top up, you have x squared. What's a negative 1x? Negative 5x is negative 6x. Negative 6 and negative 5 is negative 11. And it doesn't look like it factors. So I think I'd have to leave my answer something like this. Yes, I did make an error here. What happened to this x? Okay, how does that affect my results? Fairly significantly. So we're going back, we're going to put that x there. Right here. If this has an x, what's negative 5x times x? Negative 5x squared, right? And what's negative 5x times 1? Negative 5x. So what does this give me? Negative 4x squared, because you have 1x squared and negative 5x squared. What's a negative 1x and a negative 5x? Negative 6x, and the last constant's a negative 6. I may see if this factors. If I take a negative 2 out of this, you'd have 2x squared plus 3x. You're taking a negative 2, so it'd be plus 3. There are no factors of 6 that add to 3, so I don't think it factors. In which case, I'd probably just leave it like this. So after 7, we're moving to 8. Again, we need a common denominator. So I have 5x over x plus 8. Nothing factors on the denominator. However, over here, what factors? How does this factor? X plus 8 and x minus 3. So your common denominator is going to be x plus 8 times x minus 3. This 4x minus 9 is already over the denominator. What does this side need in the denominator that it doesn't have? It needs an x minus 3, I believe, right? So what is that? 5x squared minus 15x. So what do I get on top? 5x squared. What do these two combine to give me? Negative 11x, I think. Minus 9. All over x plus 8 times x minus 3. And that's a result for number 8. Okay, after 8, we're going to move to 9. This is two fractions equal to each other. When you have two fractions equal to each other, it's called a proportion. Proportions are usually easiest solved by simply cross-multiplying. So that means I'd have x times x plus 12, or x plus 12 times a quantity of x plus 2. Equals, if I multiplied this way, I'd have 3 times 2x plus 3. So these multiply to give me x squared plus 14x plus 24 equals, distributing would give me 6x plus 9. Making it equal 0, I would subtract 6x. And I would subtract 9. What do I get if I subtract 9 from 24? 24 minus 9, I believe, is 15. Now I'm going to factor this. I believe 5 times 3 is 15. And 5 plus 3 is 0. So, I'm sorry, 5 plus 3 is 8, which is your middle number. What makes each of these equal 0 would be negative 5 and negative 3. Looks like they'll both work because neither of them causes division by 0. I could not use negative 2 because that would force me to divide by 0. So these should be your solutions. You can always plug them in and check. If you were to replace the x, you had 2 times x plus 3 over x plus 2. Suppose you put a negative 5 in for these x's. what would I get? Would it be a true statement? That'd be 7/3 equals -10 plus 3 is -7 over -3. So I think it does work for number 9. Now I'm going to move to the last one here. This is what requires a common denominator to add or subtract fractions. So I have this. I'm just rewriting it. I may put the 2 over a 1, but it's the same thing. 2x plus 20, but I might factor this denominator to 2 times x plus 4. That means my common denominator is 2 times x plus 4. I'm able to multiply this as long as I do it to both sides of the equation. When I multiply it here, the x plus 4's cancel, leaving me 2 times 2 times x plus 7. So that's what I'm going to write. 2 times 2 times x plus 7. Minus, when I multiply here, nothing cancels, so I get 2 times 2 times x plus 4. And when I multiply here, it looks to me like the 2 will cancel, the x plus 4 will cancel, and I'll be left with simply the numerator, 2x plus 20. So this, when I multiply 4 times x, is 4x. 4 times 7 is 28. Negative 4 times x is negative 4x. Negative 4 times 4 is negative 16. And let's see what we can do with this equation. 4x and negative 4x add to 0. 28 take away 16, I believe, would leave me with what? 12. 2x plus 20. Subtract 20 and divide by 2. That gives me, okay, 7. I factored the denominators. I needed a common denominator. So I needed to multiply this one by, it did not have the x plus 1, and this one needed the x minus 3 to get my desired denominator. Nothing factored, so I left it as that. Number 8, I had to factor the denominator. To get my common denominator, I needed an x minus 3. Giving me this in the numerator cleans up to this. Number 9 is simply a proportion, a fraction equaling a fraction, which allows you to just cross multiply. So I end up with this. I make it equal 0, factor and solve. I get 2 solutions. Neither one causes division by 0, so they both work. On the last one, to add or subtract fractions, you need a common denominator. To get a common denominator, you'd have to factor the 2x plus 8 into this. So your common denominator is 2 times x plus 4. When I multiply on the first one, the x plus 4's cancel, leave me 2 times x plus 7.
Good morning, Cowboy.
Anyway, I get negative 4 for a result, and that causes division by 0, so there is no solution. Good luck.